video, but I'll kind of go through those steps fairly quickly, like I maybe talked a little bit longer about them in the video. We really want to focus on the three next steps that I talked about in the video, and we're actually going to do some examples where we finish out the partial fraction decomposition. So remember, if you watch the video, I had an opening picture where I showed a rational expression, and then partial fraction decomposition means we're going to rewrite that single rational expression so that it is the sum of two or more simpler rational expressions. So their denominators are nicer, maybe less expanded. Okay, so that's what we're looking to do with partial fraction decomposition. Here are the two steps that I talked about in the video. Okay, so most of you, I would guess, if you watch the video, you already have this written down in your notebook. Steps for partial fraction decomposition. Number one, factor the denominator. Trey gave that to us. You should always do that. Okay, that's the very first step. You've got to figure out what factors in the denominator are. Step two, write out the decomposition. That's what we're practicing in our warm-up. So there are the bullet points that tell you kind of how to set things up. It says, for repeated factors, include the lesser degrees. So that's that whole conversation. If you have an x cubed, you'll have an x cubed, an x squared, and an x. If you have a linear factor, then your numerator is a constant. So constant means we're just going to choose a single letter to hold the place of that constant. I usually use in partial fraction decomposition capital letters. So constant could be A, B, C, D. I just go in alphabetical order. Okay. If the factor happens to be quadratic and cannot be factored into linear factors, okay, then your numerator will be linear. And when I say linear, I mean in the form sort of like an mx plus b. But the only difference would be, instead of using m and b, I'll use like those same capital letters. So if it's my first one, I might say ax plus b, or bx plus c, or cx plus d, right? Just depends on where I'm at in my letters. Okay, so that would be what it looks like when I say the numerator is linear. And make sure that you never reuse the variable a, b, c, or d for a numerator. You should pick a new one for each numerator, each set that you do. Okay. The next steps to partial fraction decomposition, step 3 is going to be to simplify. And when I say simplify, what I mean is we are going to then change that equation. So what we wrote out in the warm-up, we're going to change that equation so that it doesn't look like fractions anymore. Because solving an equation with 3 different fractions, then all of those variables would be a little overwhelming. So we want to make it look like it's all on one line. And in order to do that, we're going to multiply by the least common denominator, the LCD. You used the LCD last year if you were in Algebra 2, and if you were in Algebra 3, you used it as well, to solve rational equations. So if you had an equation and you wanted to solve for x, you would multiply the whole equation by the LCD. We have LCD and cross multiplication. Okay, so you have used that method before. Again, a nice little check for you is, have you eliminated denominators? Because if you have still denominators left over, then you didn't multiply by the LCD, or something went wrong. Okay. Step 4. After you get that nicer equation, I call it a basic equation, just so that we all refer back to the same equation. When you get that basic equation, you're going to start solving for your constants. Remember, your constants are those capital letters, A, B, C, however many you have. In order to solve for the constant, my recommendation to make things go a little bit more smoothly is to choose the zeros of your factors as numbers to substitute in for x. So that will become more clear in our example. But let's say we had a linear factor of x minus 30. Then we would choose the 0 of that linear factor. The 0 of x minus 3 is x equals positive 3 because it makes the thing equal 0. So we would then let x equal 3. And what's really nice about that is for whatever gets multiplied by that linear factor, 3 minus 3, that's equal to 0, so then that piece cancels out and we have less to work with. You don't have to choose the zeros. If you don't choose the zeros, things won't cancel right away. Then you would be creating like 2 variable systems, and you would, after you create 2 equations, then you would still have to solve a system. So by choosing the zeros, you're doing less work. And so I recommend doing that. And then the last step is write the decomposition. Once you have solved for all the constants that you had labeled in your original partial fraction decomp, like we did in the warm-up, then you just plug those numbers in for all the numerators and you have the partial fraction decomposition. And so you've broken up that larger rational expression into the sum of smaller or simpler rational expressions. Okay. So the first 2 examples are going to be the examples from the warm-up. We already know how we would set them up. So the first example I have is that very first example from the warm-up, x plus 8 over x squared plus 6x plus 8. Step 1, given to us by Trey, is factor a denominator. We already said this is x plus 2, x plus 4. And we noted that these are both linear factors, so we would have constant numerators, a over x plus 2 plus b over x plus 4. And we're all in agreement that that is partial fraction decomposition, first 2 steps. So now we're ready to move on to step 3, which is we don't want to have this rational expression equation. We'd like it to be sort of all on one line. We're going to get rid of those denominators. So we're going to multiply by whatever the LCD is. A quick hint, the LCD is always the denominator of the original rational expression. Right? It has to have all those factors so that we can cancel out this whole denominator. So my LCD is x plus 2 times x plus 4. And I want to multiply the whole equation by x plus 2, x plus 4. I'm going to write that out this time. So I'd multiply the left side by x plus 2, x plus 4. Then I'd multiply the right side by x plus 2, x plus 4, and that would distribute to both terms that are being added. So this first fraction gets multiplied by x plus 2, x plus 4, and the second fraction gets multiplied by x plus 2, x plus 4. So I'm writing it out so I can see that I'm multiplying the entire equation by that LCD, and that is distributing to all the terms. So on the left side, on the right side, separate things are being added or subtracted. So the benefit of this is, if I multiply this left side by all the factors in the denominator, what happens to the factors in the denominator and then the LCD in the numerator? They're all going to cancel out. So I can cancel out everything, and the only thing that's left over is x plus 8. Well, that looks a lot simpler over there. Then I move over to the right side. I'm multiplying all the terms by the LCD. For this first fraction, a over x plus 2, the only thing that will cancel out when I multiply it by the LCD is x plus 2. So that means that I'm going to be left with a times x plus 4. And on the second fraction there, I would cancel out the x plus 4, so I'm left with b times x plus 2. So that equation right there is what I would call your basic equation. It looks a lot nicer than the one that had all the fractions, right? And we feel more confident about solving this equation. So here's the big issue. I want you to solve for those constants a and b, but right now you have a, b, and x. So it'd be great if we could kind of sub in for 2 at a time, but we really don't know what a or b is. By using my hint from step 4 to use the zeros, okay, think about over here on the right side, I've got a times x plus 4 and b times x plus 2. I could choose wisely for my x value so that one of these factors is equal to 0, And then I'd be plugging in for x, and at the same time, I'd be getting rid of either a or b because it would be multiplied by 0. And that would leave me with one variable left to solve for. So what value of x shall we choose? Let x equal -2 and -4. Doesn't matter which one you start with. Okay, I'm going to start with let x equals -2. I have to go to this basic equation. I've got to plug -2 in for all the x's. -2 plus 8 is 6. Equals a times -2 plus 4. 2. Plus b times -2 plus 2, which is b times 0. Well, b times 0 is 0, and 2a plus 0 is just 2a. So I have 6 equals 2a. Now I know a is equal to 3. Now, I could take that and plug that in with some other x and try to find b, but I could also just do the other 0, right? Let x equal -4, like someone suggested. So now I plug in -4 for all the x's. -4 plus 8 is 4. Equals a times -4 plus 4, which is 0. Plus b times -4 plus 2. That's -2. The a times 0 is 0, and 0 plus -2b is just -2b. So I have 4 equals -2b, so b is -2. So I have now very quickly found my two constants. I just have to plug those into my partial fraction decomposition. I usually go back up to that very first line that we did, like what's in the warm-up, and I usually write down the left side too. So I usually write like x plus 8 over x squared plus 6/8 plus 8 equals a is 3 over x plus 2. And then I have b as -2, so I can either write plus -2 or I could say minus 2 over x plus 4. And I have my answer. Is there anything from that process that you want to talk about or clarify, or we have questions or concerns? Choosing the zeros is not the only way to solve that. You could pick other x's besides -2 and -4. They won't cancel out an a or a b, so then you'll still be left with a or b, but you could plug in another x and create a two-variable system. So you can solve that elimination.
Where would that be used?
You'll use it again in calculus to like break up a rational function. I can ask Mrs. Hillman where she exactly uses it in Calc AB. But it's kind of funny. We do it and then we don't do anything with it, which is a lot of what we do in calculus. It's kind of like this hodgepodge of all these skills you need, but we don't do anything with them. But you'll see it again in calculus. I would need a reminder about exactly what we do it for. Okay. Probably derivatives or something, I would guess, because it would be easier to do the partial ones. Okay, next example is the second example from the warm-up. 3x squared minus x plus 5 over x cubed minus 2x squared plus x. And we have already set up the first two steps. Ethan gave us the factors in the denominator. X times x minus 1 squared. And then we wrote that out as a over x plus b over x minus 1 squared. And since that's a repeated factor, we have to include c over x minus 1 to the first, which is just x minus 1. So this means in my solving, I'll have to do a little bit more work, because not only will I have to find a and b, I'll also have to find c. So when you have more variables, you got more work to do. This is step 1 and step 2. So we're ready for step 3, which is multiply by the LCD. the LCD should always be the denominator of the original thing. So if you factored the denominator in step 1, you know what all the factors to the LCD are. Okay. Now I'll write down those pieces one more time. On my next example, I won't show myself multiplying by the LCD anymore. And as you practice your homework tonight, you can decide at what level you feel most comfortable in being successful. Like, do you need to show that you're multiplying that by all the terms so that you can, like, physically with your pen and pencil cross off the things that cancel? Or can you do some of that in your head? Because in the next example, I'll do the canceling in my head. So that's totally up to you where you feel your comfort level is. Cancel, to simplify, so x times x minus 1 squared is going to cancel everything. We'll just have 3x squared minus x plus 5. In my first fraction, I can only cancel out the x, so I'm going to be left with a times x minus 1 squared. In the second fraction of my decomposition, I can cancel out the x minus 1 squared, so I'm left with bx. And in the last one, I can cancel off one of the x minus 1 factors, so I'm just going to cancel off that exponent, and I'm left with cx times x minus 1. Okay, so it has 2 factors left over. Can you talk in your small groups really quickly and decide what numbers are you going to substitute in for x to solve? You're going to let x equal what? Okay, Taylor, can you give me one number you guys are going to sub in?
0.
Okay, so we're going to let x equal 0. And Catherine, can you give me another number?
1.
What did you say?
1.
1. That's what I thought, but it did sound like 40 from up here. So I thought, yes, you could do 40 if you wanted to. I wouldn't. Okay, so let x equal 0 and let x equal 1. Will you guys practice plugging those in and see how your equations solve? So remember, you're plugging it in for all the x's in the whole basic equation. I'm going to come up here and highlight my basic equation in green. I'm going to box it for you. You're plugging that 0 in for all the x's in this equation. See if we can simplify that. Find some variables. Constants. Yep. And the other one. And if you get 2 answers, see if you could devise or hatch a plan to find your third one. Okay, so on the board, I've kind of joined up with you, and I just subbed in the value for x. So on the left side there, if I plug in 0 for x, the 3x squared and the minus x will cancel out, and I'll just have 5. And then I have whatever is in those linear factors, and I sub in the value for 0. So this leaves me with something like 5 equals -1 squared will be a +1 times a, so a, and then plus b times 0 plus c times 0 times -1, that's all going to be 0, so I now have a, correct? And something very similar happens over here when I let x equal 7. I'll have 7 equals, the a times 0 squared will just be 0. I'll have 1b, but then c times 1 times 0 is also 0, so I just have b equals 7. So some groups I heard chattering, what do you notice happens each time? The c will cancel out, right? You're choosing the 0, and then c has each of those factors, so you can't keep c long enough to solve for it. What are some ways that you might now be able to solve for c? David?
Just
Plug in a and b, and then you'll still have c's and x's. So along with plugging in a and b, plug in some number for x. Does it matter what number you choose? No, you just don't want to choose one of your zeros again, or c is going to cancel. So choose any number besides 0 and 1 for x. Okay. So I would say, let x equal, what do you guys want to do? 2, that's a good one. And so then, a equals 5 and b equals 7. Okay. So if I plug into 3 times 2 squared is 12, minus 2 is 10, plus 5 is 15. That's equal to 5 times 1 squared plus 7 times 2 plus c times 2 times 1. So I'm just plugging 2 in for the x's and kind of simplifying those factors as I go. And that leaves me with 15 equals, this is 5 plus 14, so 19, and then plus 2c. Are we okay with my algebra? You might do it in like a different order, or you might simplify faster or slower than me, but we should come up with the same equation. And then when you solve this, you get negative 4 equals 2c, so c is equal to negative 2. So now we can take that value, c equals negative 2, along with a and b, and plug it into our original work to have our final partial fraction decomposition. So I would write something like this: 3x squared minus x plus 5 all over x cubed minus 2x squared plus x equals, is a 5 and b is 7, and c we said is negative 2, right? Now I put minus 2 over x minus 1. You can do plus negative 2 over x minus 1. Same thing. Okay? Any questions there? Okay, very good. Our last example that we're going to do, we didn't do a setup in the warm-up, but this is an example where when we factor our denominator, we'll have one quadratic factor. So you'll get to see one example like that as well. Okay, so this is our last example. Go ahead and write this down. 5x squared minus x plus 27 divided by x cubed plus 9x. Step 1 would be factor your denominator. On this one, you only have 2 terms. You got x cubed plus 9x. Greatest common factor. What do they both have in common? X. So we'll factor an x out of both. That gives me x times x squared plus 9. And then that will allow me to set up my partial fraction decomposition. This factor of x is linear, so it's going to have a constant for the numerator. This factor cannot be factored further, x squared plus 9. So I'm stuck with a quadratic factor, which means its numerator is going to be linear. Remember, that's when I said think mx plus b. Okay, so when I write out my partial fraction decomposition, it's going to look something like a over x plus bx plus c, mx plus b. Linear form, all over x squared plus 9. Because it's quadratic and it can't be factored in.
So it doesn't matter what quadratic you have,
Yeah, well, it could be any set of letters. Like if it's your first factor, then you might write ax plus b. Because I already used a, I just went to the next letter, bx plus c. If I had an a and a b already used, then I would have cx plus b. But it will always be of that form. Good. Okay, now I'm going to multiply by my LCD, and this time I'm not going to write it down every time, because I know on the left side, if I multiply by the LCD, the whole denominator goes away, and I just have 5x squared minus x plus 27. When I multiply the right side by the least common denominator, x times x squared plus 9, this first fraction is only going to cancel out the x. So I'm going to have a times x squared plus 9. And then the second fraction, when I multiply by x times x squared plus 9, I'm going to be able to cancel out the x squared plus 9s. So I'm going to have plus bx plus c times x. Okay. Now, if you actually need to see that, then you write the LCD right next to all the fractions and you cancel things. So you decide where you are at, and you go with whatever works for you. Okay, when you look at your basic equation, do we have any ideas of where to start? What's that? No? 0. Why do you say 0, Raven? If you let x equal 0, this whole thing is being multiplied by x, which if that's 0, that whole bx plus c is going to cancel out, right? Okay, so let's let x equal 0. That will give me 27 equals a times 9 plus, and then it would be b times 0 plus c, which that wouldn't cancel out everything. I'd still have a c, right? But then when I multiply it by 0, then it becomes 0 and everything cancels out. So I have 9a equals 27, therefore a is 3. Ideas for what to do next? Pick in any number for x except for 0 and plug in a. Okay, so let's let x equal 1. And I'm just going to do this interestingly on this one. I'm not going to plug in a just yet. We're going to see what happens if I don't plug in. Do I want to plug it in?
Yeah.
Okay, and plug a equals 2. Okay, 5 times 1 squared minus 1 is 4 plus 27 is 31 equals 3 times 1 squared plus 9, that's 10, plus b times 1 plus c times 1. So that's going to be 31 equals 30 plus b plus c. And so you might subtract 30 from both sides and get 1 equals b plus c. Can you solve for b or c right now? No, so what might you do? You have two unknowns.
Can we plug in x equals 2 and make a system of equations?
Yes. Choose another value for x, plug it in with your a value like you just did, and you'll have created a system of equations. So now David said let x equals 2 and a equals 3. So that would be 2 squared is 4 times 5 is 20 minus 2 is 18 plus 27 is 45 equals 3 times 4 plus 9 is 13 plus b times 2 plus c times 2. So that's 45 equals 39 plus, this is 2b plus c, but then we distribute the 2, 4b plus 2c. I know I'm doing the math pretty quickly there. You could take your time and do it right. Move that 39 so we get 6 equals 4b plus 2c. And then we have two equations with b and c, and we could solve by elimination. I would maybe multiply this first one. I'll call this A. No, I'll not use A. I'll call this equation 1, and I'll call this equation 2. And so I'll maybe take 1 times negative 2. So I get negative 2 equals negative 2b minus 2c. And then stack equation 2 right under it. 6 equals 4b plus 2c. So I find out b is 2. And then I could sub that back into the first equation. 1 plus 2 plus, or 1 equals 2 plus c. So c equals negative 1. And now I have A, B, and C. So I'm ready to plug those in. Okay, now these two, B and C, will be part of my linear factor that's in my numerator. So when I plug it in to the original, I'll say, what did we say A was? 3? 3 over x plus 2x minus 1 over x squared plus 9 equal to that other expression. Now you do have a homework assignment on your gold sheet. Okay. Please do your homework tonight so that you can be ready for the partial fractions quiz tomorrow.
Sorry.